unit conversions for a little bit. You can review this video to help with it. There's two factors you need to learn about unit conversions. And you can do any conversions in chemistry as long as you follow these two rules. Conversion are one of the toughest things most students struggle with. And the first rule is you're going to multiply by 1. If you multiply by 1, you never change a number. You just convert the units. So if the numerator and the denominator are equal, that's 1. So if you know the metric system, say we have milligrams, and divided by milli means 10 to the negative 3 in the metric system. So that's a conversion number. This is multiplying by 1 because milligram and 10 to the minus 3 grams are still the same thing. If we multiply by, if we had kilogram, kilo means 10 to the 3rd. Again, that is 1 unit. And it's 1 as a value of 1. So all we're doing is changing the units. If you multiply by, say we got micrograms, say we got 10 to the minus 6 grams, 10 to the minus 6 in the metric system is microgram. So as long as we keep our numbers equal to 1, we'll get the answer right. So your first step is multiply by 1. The second step is to make sure that units cancel. So if we have a conversion, okay, where we're going to go from grams, say we have 10 grams, and we want to convert that into milligrams. Milligrams goes on top. Milli means 10 to the minus 3 grams. Okay, and you see grams cancel. And you're left with milligrams. 10 to the minus 3, it comes out to 10 to the 4th milligrams. Okay. But remember, we bring a number up, we change the sign. So it's 10 to the 3rd times 10 to the 1 is 10 to the 4th. Okay. And we're left with milligrams. So we did two things. We made sure our units canceled. This number on the top, this unit on the top was this unit on the bottom. Grams cancel grams. Okay. And we made sure we were multiplying by 1. And that's how you do conversions. It's those two rules, and you'll get it right every time. And most students have a hard time knowing what to put on top, or know what to put on bottom, how to do the math. We'll go through a couple of them and convert it. We can convert from the metric to the metric system, English system to the English system, or we can convert English to metric or metric to English. You do any of those conversions. Say you want to convert, let's give an example here. Say we have 3.78 times 10 to the 9th inches. Okay. And we want to convert that into, say, kilometers. We want to go to kilometers. All right. So most students have trouble figuring where to start. We start with what number is given to us. All right. So we're starting with 3.78 times 10 to the 9th. So let's write that down. So 3.78 times 10 to the 9th inches. We want to convert that into, first of all, let's get into the metric system. So you can go with a conversion of inch, and now you have to have inch on the bottom, so you go inches. And we know there's 2.54, whoops. There's inches. We know there's 2.54 centimeters in 1 inch. Okay. Again, we multiply by 1. 1 inch is the exact same thing as 2.54 centimeters. And on in your Canvas course, there's a data packet. I think it's not direct. You look under the modules, you'll see something called a data packet. It gives you all the metric terms, everything else. Kind of handy, had it all in one spot for you. Okay. So now we're in centimeters. So what has to go on the bottom here? Centimeters has to go on the bottom, so it cancels. And centi is, in the metric system, 10 to the minus 2. So instead of writing C, I can write 10 to the minus 2. Okay. Now I'm in meters. So what has to go on the bottom again? Meters has to go on the bottom. I'm trying to get to kilometers. And kilo is 10 to the 3 meters. That's it. That's the number we want to end up with, is kilometers. So now we just do the math. If the numbers are on the top, multiply, the bottom, we divide. With exponents, we bring it up to the top and we change the sign, 10 to the minus 3. So we get 3.2, take 3.6. What we're going to do is take 3.78 times 2.54. And everything else is exponents. So let's get a calculator out. And we're going to say 3.78 times 2.54. And that's going to equal 9.6012. Like we talked about yesterday, we're only good to 3 significant digits because we multiply and divide. Okay, we take the number with the least amount of significant digits. Adding, subtracting, we take the least accurate number. Okay. And this conversion numbers are considered exact numbers. So 2.54 is not a measured value, it's a conversion value. So our only measured value is 3.78. So we're good to 3 significant digits. So it's 9.60. You can't leave a 0 off because it is significant. It's a measurement that we have achieved, an accuracy. And then we've got 10 to the 9th times 10 to the negative 2, excuse me, times 10 to the negative 3. When you multiply integers, you just add. So 9 minus 2 is 7. 7 minus 3 is 4. So times 10 to the 4th kilometers. So 3.78 times 10 to the 9th inches is equal to 9.60 times 10 to the 4th kilometers. Okay. That's how we do conversions. That's it in a nutshell. No matter how long it is, and there's more than one way to do it. I could have gone from inches to meters by looking up the inches to meters conversion. I could have gone from centimeters to kilometers. Okay. This is just one way of converting that makes sense to me. Every single number we've converted is equal to 1. Okay, there's 2.54 centimeters, the exact same thing as 1 inch. A centimeter is 10 to the minus 2 meters. Kilometer is 10 to the 3 meters. Now you always have to notice we put each one so they cancel. That's how you determine what goes on top, what goes on bottom. Whether the second one here, whether centimeters go on top or on bottom. It has to go on the bottom because inches have to cancel, centimeters have to cancel, meters have to cancel, and now you're left with kilometers. So follow those 2 rules. Multiply by 1 and make sure your units cancel. From on top goes to the bottom. Then you'll do great. That's what conversions are all about. So let's take some other ones. So it's gonna get a little trickier than that, but we'll just follow those 2 principles, you'll do really well. Okay. Let's say we have energy conversions. We'll do energy in the chapter 6, I think, and we measure energy. Energy is measured in joules. Okay, that's our measurement for energy. And we know one of our conversions is there's 4.184 joules, joules per calorie. Because calorie we measure as the amount of energy it takes to raise 1 gram of water, 1 degree centigrade. Okay, that's the energy that it takes. And we convert it to joules with that number. So if we do an experiment and we say it gives off 150.0 calories. Okay. We don't know how many joules that is. So we give off 150.0 calories. Okay, so we start with 150 calories. Does calories go on the top or bottom? Calories has to go on the bottom, so it cancels. So calories go on the bottom, joules go on top. How do I make this equal to 1? 4.184 joules is equal to, that's a 4, 1 calorie. So this is multiplying by 1. We're not changing the value, we're simply converting different units. Calories cancel. Those are our 2 steps. Make sure our units cancel and make sure everything is always multiplied by 1. So we have 150. .0 times. It's on the top we multiply, the bottom you divide. There's no parentheses, none of that, just plain simple rule. Keep it simple. If it's on the top, multiply, on the bottom, you divide. I know it sounds simple, but a lot of students mess that up, especially when there's more than one number on the bottom. 150.0 times 4.184 equals 627.6 joules. And how many significant digits? We are good to 4 significant digits or figures. And this has 4 significant digits right there. So that keeps our number. Okay. Remember, you can't make numbers more accurate or less accurate by mathematical manipulation. You have to keep the same measured values, the precision or the accuracy of that number. That measured number. All right, let's try some different ones. Let's do. All right, say we have 0.0129 inches. And I want to convert that into micrometers. That's your problem. So basically, I'm taking a word problem, I'm putting it into chemistry terms, and now I'm going to solve it. So we start with 0.01129 inches. Okay. So what has to go on the bottom? Inches has to go on the bottom. And there's 2.54 centimeters per inch. Okay. And then we have centimeters on the top, so centimeters have to go on the bottom. And centi is 10 to the minus 2 meters. Okay. Now what has to go on the bottom? Meters has to go on the bottom. And we want to go into micrometers. Micro means 10 to the minus 6. Again, everything is equal to 1. Every conversion unit here, every grouping. Okay, there's 2.54 centimeters in 1 inch. There's 10 to the minus 2 meters in 1 centimeter. And there's 10 to the minus 6 meters in a micrometer. So what determines what goes on top is determined by canceling the digits out. Okay, canceling your units. Inches on the top, on the bottom, on the top, on the bottom, on the top, on the bottom. The units have to cancel. Those are your 2 rules. You have to multiply by 1, and you have to make sure your units cancel. Follow those 2 rules. You're on your track to getting it right every time. Okay, this is the hardest thing for most students. It's conversions. Like I said, go over this. I mean, you're not here now. You go over this. I'll post all these on my website on the Canvas site. It'll be on the home page. You go down to the bottom of the home page by the dog, by Pumpernickel. That's the dog. Okay, and the thing that says videos. Click on that. It'll say session 1, session 2, session, etc. As I record those, I'll put those on. I'll put on session 1 tonight, and session 2 will go up tomorrow. Okay, so we take 0.0129 and times 2.54. Again, the top, whoops, equals 0.032766. That's what comes out on the calculator. And then we have 10 to the minus 2. And we have 10 to the minus 6. We bring this up, it becomes 10 to the 6. That's a minus 2 right there. Not very good. 10 to the minus 2 and 6. And then we multiply exponents, we add them, right? So you have 10 to the minus 2, and then you brought that 10 to the minus 6 up to 10 to the 6. So negative 2 plus 6 is 4. Can I leave my answer like that? No, 2 reasons. First reason is I wanted a scientific notation, which is what we're going to be using, and it has 2 significant digits. How many significant digits can the answer have? We have only 1 measured value right here. Remember, leading zeros are not significant. Okay? They're placeholders, just like trailing zeros are not significant unless it's after a decimal point. Okay, those are our rules. So this number has 3 significant digits. Okay, so it's going to come down to 3 right here. So this is going to be 0.032. And if this number here is greater than 5, it goes up. If it's less than 5, it goes down. If it's exactly 5, it goes up. So 3, 2, and that becomes 8. All right, so then we got times 10 to the 4th micrometers. Okay, now let's put a scientific notation. Scientific notation, we're going to move that decimal to make our number between 1 and 10. So we're making 3. So it's going to be 3.28. And we made this number bigger by 2. 0.0328 is a lot smaller than 3.28. So we made that number bigger. So we have to make our exponent smaller by the same amount. So we moved it we made it 2 digits. Okay, we moved it 2 digits and made the number bigger. So we have to make this number smaller by 2. So take 10 and then minus 10 to the minus 2. So 10 to the 4th, 10 to the minus 2 becomes 10 to the 2 microns. Okay, you could also put 328 microns, same exact number. This is in scientific notation. And the other one is just the regular digits. So it's 328 micrometers or micrometers, or 3.28 times 10 to the 2 micrometers. All right. I hope that's making some sense there. All right, let's take, do something a little bit trickier here, just in case that's not a good enough challenge for it. Okay, let's convert, say you're wanting to buy a muscle car, and they say this new turbocharged Mustang does, say, 9.78 times 10 to the 3 miles per hour, let's go centimeters per second. Okay, you know, how fast is that in miles per hour? So let's convert this number into miles per hour. So we start with 9.78 times 10 to the 3 centimeters per second. So we're going to convert centimeters. We're going to convert this top value into miles, and I'm going to convert this bottom into hours. That's where we're headed. Let's do the top one first. Top one is centimeters on the top, so centimeters on the bottom. And there's 2.54. I didn't do that for a minute. There's 2.54 centimeters in an inch. That gets into the English system because miles are in English. And I know the feet to miles, so let's convert this into inches. Let's carry this, I want to go into feet. And there's 1 foot is 12 inches. Right? Yeah, 12 inches in a foot. I know there's 5,200 feet in a mile. So you can use any numbers you want. You can go to yards. You can go to miles. You want to do the inches to it. I just happen to know these off the top of my head, these conversions. And 1 foot, what did I say, 5,280 feet are in a mile. Okay, now we got miles. We stop the top ones. Okay, now let's do the bottom ones. The bottom ones are seconds. I know there's 60 seconds in a minute. Okay, that allows me to go from seconds to seconds. Okay. And I know there's 60 minutes in an hour. Yeah, and now I got hours. I've got miles per hour. Those are my units that are left. So double check. Every single step we took has to equal 1. 2.5 for centimeters is 1 inch. 12 inches is a foot. Same exact thing. 1 mile is 520 feet. 60 seconds is a minute. 60 minutes in an hour. Make sure everything cancels. Centimeters, cancel. Inches, cancel. Feet, cancel. Seconds, cancel. Minutes, cancel. What are we left with? Miles per hour. Okay. So let's go and do our math. Remember, if it's on the top, you hit multiply. The bottom, you hit divide. Most students are going to make the mistake of going, let's close the door real quick. The dog had to go out. Nico, what are you doing? Come here. All right. So doing the math, most students are going to make the mistake. They'll go like 9.78 times 10 to the 3 divided by 2.54 times 12 times 5,280 times 60 times 60. You don't group them together. If the number is on top, you hit multiply. If the number is on the bottom, you hit divide. Okay? Just keep it really simple. I'll go through it with the calculator, what I do on my calculator. All right, 9.78. I'm going to say the 10 to the 3rd till the end. Divide 2.54. So hit divide 2.54. Then hit divide 12. Then hit divide 5,280. Then hit times 60 times 60. And it comes out to 0.21877237, and we put our 10 times 10 to the 3rd. Okay. So let's move our decimal point 3 places. This times 10 to the 3rd. So 1, 2, 3. Okay, that comes out to 218 miles per hour. Okay, that's a good speed for most of the car. Ford Mustangs, turbocharged. That's a good power. That's a good buy. I would buy that one. 218 miles an hour is pretty quick. So that's how you do conversions. We can convert denominators, we can convert numerators, we can convert both. Just remember those 2 rules. Multiply by 1, because that doesn't change the value, it just converts the units. And then make sure everything cancels. If it's on the top, on the bottom, top, bottom, top, bottom. Make sure everything cancels. All right. So that converts those. Just kind of go through the book and making sure you got all the conversions that we need to help you with chemistry. And again, go through these examples, work them. And then if you want more examples, I'll email you more examples. Email me if you have trouble with any of these problems. I'm going to cover cubic inches, and then we'll do density, temperature, and basically finish up until this chapter. So let's do that. All right. Now we can deal with square areas too. Say you have a cornfield, and this cornfield is 328 yards by 297 feet. How many, and say you have to search this for a murder suspect. We do a lot of forensics. So what's the area you have to search in, let's say, centimeters cubed, centimeters squared, I'm sorry. Areas are squared, the 2 values. All right. So first of all, you got to realize you're dealing with 2 different units, feet and yards. You got to convert everything to the same unit. And we want to express that answers in cubic centimeters, because when you're dealing with the European police, things like that, Scotland Yard, you have to convert into metric units. They don't use English units. So you have to do a report of how much you had to search, and you want it in square centimeters, you got to convert. So let's just convert each one into centimeters. Okay. 297 feet, and feet go on the bottom. And there's 12 inches per foot. Okay, so we have 12 inches. And inches we have 2.54 centimeters per inch. That converts this value into centimeters. We have to compare apples to apples. We have to multiply by the same number to get the correct units, or the number doesn't mean anything. Now we got yards. Let's convert yards. There's I don't want to do this. Let's convert this into, let's convert it into feet again. So yards is, there's 3 yards. Wait, it's 3 feet in the yard. Gotta make sure you put your numbers right. So we have yards on the bottom, so it cancels, and there's 3 feet in a yard. Now this is a little different conversion this time, just so it can show it still works. And we have 3.28 feet in 1 meter. In 1 meter, we go to centimeters, and centi is 10 to the minus 2 meters. Okay, so both those conversions are going to get us into centimeters, which is it. There's multiple ways to do this. As long as you follow the 2 rules, you'll do it right. So the top number is 297, and then times 12 times 2.54. So your top value is, and it's 905,256. So let's say it's 9, and it's 3 significant digits, so 9.05 times 10 to the, and this is 1, 2, 3, 4, 5, 10 to the 5th. Okay. Doesn't seem right for some reason. Seems too big. 297. I had the numbers. Let me double check. 297 times 12 times 2.54 equals. And that's, oh, 3. There's only, it's 10 to the 3rd. That's right. I did put that wrong. 10 to the 3rd. So 9.05 times 10 to the 3rd centimeters. Okay. Bottom one is 328 times 3 divided by 3.28 equals 300. So 3 single digits, 3.00 times 10 to the, and the negative 2 comes up, becomes 10 to the 2 centimeters. I'm trying to think that looks right. So let me just check that again. 297. Times 12 times 2.54. 9,000. 9.05 times 10 to the 3. Yep. And yards. How many yards? 3 feet in the yard. 3.28 feet in the meter. And centimeters, 10 to the minus 2 meters. So let's just double check the math here. 328 times 3 divided by 3.28 equals 300. Oh, 300 times 10 to the 2. That comes up. So 3.00 times 10 to the 4th Sorry. I knew it didn't look right. Couldn't have a bigger number there. So the 10 to the 2 comes up. Okay, so this was 300 times 10 to the 2. So it's 3.00 times 10 to the 4th. We made this number smaller by 2. Make this number bigger by 2. So these are two numbers in centimeters. To get the area of the field, we multiplied length times width. Okay. So we're going to take 9.05 times 10 to the 3 times 3.00 times 10 to the 4th, and we're going to get 9.05 times 3.00, because that is 27. .15 times 10 to the, and we multiply exponents, we add together, 10 to the 7 square centimeters. And we're only good at 3 significant digits. So we have the digits to there, and we're going to move this decimal point to your sign to notation, one place to left. So we made that number smaller, we went from 27 to 2. So we make that smaller by 1, we make our exponent bigger by 1. So 2.7, and again, this is exactly 5, so this rounds up. 2.72 times 10. And again, that made that smaller. We make this bigger. 10 to the 8 square centimeters. That is the area of a field. Okay. There's multiple ways to do it. You just got to make sure the units are the same when you convert. If you want to do area, you square it. If you want to do volume, you cube it. So it'd be centimeters cubed if it was a volume, and squared if it's an area. We'll do a lot more practice with conversions. And let's do one conversion here for all right, let's do a volume. Let's say the liquid has a volume of 15.3 cubic centimeters. What is the volume in liters? Now there's a trick we use when we deal with volumes. A cubic centimeter is equal to a milliliter. That's one of the conversions. It's in the data table I talked to you about, but that's one of the tricks that we use. So we got 15.3 cubic centimeters. What that allows us to do is go from a measured volume to a liquid volume. This cubic centimeters is a measured volume. It's length times width times height. Okay, whether it's cubic meters, cubic millimeters, cubic centimeters, you want to get in cubic centimeters, so it equals a milliliter. So a cubic centimeter is the same thing as a milliliter. And milliliters go to liters. What does M equal? M is equal to 10 to the negative 3. Okay. So we get 15.3 as our answer. 3 significant digits, 15.3 times 10 to the negative 3. So if we don't want to get assigned notation, we just move our decimal 3 places to make it, because this is to make it smaller. We make our number smaller by 3, 10 to the negative 3. We move the direction to the left. So we're going to do this 1, 2, 3. So it was 0.0153 liters. Okay. Again, 3 significant digits. Leading zeros are not significant. Okay. So let's do a couple more things and we'll call this a night. Okay, we'll do density. Density equals mass divided by volume. So if you're looking for a certain density of something, you take the mass and you divide it by the volume. Okay. Say we have a bullet found in a crime scene. You want to know the density of that bullet, because you know the density, that you can take a chart and compare it to different materials that have different densities and find out what that bullet's made of. All right. So let's say we go to the lab and we have this bullet that's been expended to the right. That's all squished on the end. Okay. kind of mushroom shaped. That's how bullets end up when you fire them. They don't keep their pretty cylindrical shape. Okay. So let's say we weigh the mass of that bullet. We weigh it, and it has a mass of 2.793 grams. Okay. Then we take that same bullet, we dry it off, and we place it in what's called a graduated cylinder. This is filled with water, and it's filled exactly to 30.00 milliliters with water. And we take this bullet, and we're going to drop it into the water. And what's that kind of water to do? The water is going to raise depending upon the volume of the bullet. Just like when your child gets in the bathtub, the water level goes up depending upon the mass of the child. Okay, so say the water, we add the bullet to it, and the water goes up to 34.00 milliliters. Okay, so we know the bullet has raised the water 4.00 milliliters. So there's our volume, there's our mass. So the density of that bullet is going to equal 2.793 grams divided by 4.00 milliliters. Where density equals, and for the calculator, you hit 2.793 divided by 4.00, comes out to 0.69825 grams per milliliter. Okay. That's our density. Is that the right answer? No. How many significant digits? Top number has 4. Bottom number has 3. Remember, zeros are significant if they're after the decimal point, because that doesn't change value. The other place are there is because we know to measure that value. So we're only good to 3 significant digits. We're only good to right there. So it's 0.698 grams per milliliter will be the density of the bullet that was fired at found at Ramsey. And that's how we use density. Again, if you're given any of those 3 values, if you're given any of the 2, you solve for the third. We can algebraically rearrange this equation. Okay? If we want density, it's mass over volume. If we want mass, it's density times volume. Okay? I just move this to this side of the equation. If I want to find volume, volume is equal to mass divided by density. So no matter what I'm looking for, I can algebraically rearrange my equation to solve for what I want. So if I'm given the density, and I can weigh the bullet, find its mass, I can figure out its volume by taking the mass divided by the density. And the same thing, I'm given the density, if I know the density of the metal, and I know the volume that it occupies, I can find how much it's going to weigh, how much the mass is, by density times volume. All from this formula right there. And we'll get into rearrange these formulas a lot with pressure or pressure laws, PV laws, pressure, volume, and temperature laws. Okay, so it's density. And then we're going to talk about temperature, and that will do it. Again, if you have questions, definitely go through this and email me, because conversions are the hardest things for most students. So we have 3 temperatures. We have degrees centigrade, which is normally used. We have degrees Fahrenheit, which is used in the United States, and we have Kelvin. Kelvin is not a degree. We have degrees centigrade, degrees Fahrenheit. Kelvin is not a degree. Kelvin is a measurement of energy. At 0 Kelvin, all movement stops and the world ends. Okay? I remember what an atom with the nucleus in the center, all these electrons spinning around it. Okay? If movement stops, all these electrons stop spinning. Okay? You got positive nucleus, you got negative electrons, they slam together and condense. Okay? So Kelvin is our what's called absolute 0. You cannot go negative Kelvin. That's how we use it, because you can't have a negative value. You could have negative centigrade. You have negative Fahrenheit. minus 32 degrees is freezing. But you can never, never have negative Kelvin. And Kelvin never has a degree sign on it. Okay? So you can convert from centigrade to Fahrenheit to Kelvin. And the formulas are degree Fahrenheit, okay, is equal to 9/5 your degree centigrade plus 32, is it? Yeah, plus 32. Okay, and then rearrange that. let's solve for degree centigrade. Let's move around algebraically. Okay, degree centigrade is going to equal degree Fahrenheit minus 32, and then times 5 divided by 9. Okay, you just move that, just use your formula to move it around. So we can move that around any way we want, and we can always convert from degree Fahrenheit to degree centigrade. And Kelvin equals your degree centigrade plus 273.15. So if you have a 25 degrees centigrade, roughly room temperature, it's 298.15 Kelvin. So with those three forms, we can convert anything we want. Let's say we're given, let's do one example. And like I said, if you want more examples, just email me, we'll do all kinds of examples as we go through this course. That's what I'm here for. I'm just here to show you how to do the math so you can succeed in chemistry. This is, there's no grade with this class. It's here to help you to get through chemistry, because chemistry can be very challenging. And if you know the math part, you got a big step up on other people in the class. Right? So let's say we're in the United States and we're 105 degrees Fahrenheit. Typical desert day out here. Okay. And my grandkids are visiting right now from Ireland. Everything over there is in degrees centigrade. So they want to know how much it is in degrees centigrade and in Kelvin. I want to know how much 105 degrees Fahrenheit is, the centigrade and Kelvin. So I know Fahrenheit, so my degree centigrade. So remember, we did a calculation, degree centigrade equals 5/9. And then our degrees Fahrenheit minus 32. Okay. So 5/9 degrees Fahrenheit is 105 minus 32. And that equals. Now, doing the math, you cannot do 5 divided by 9 times 105 minus 32. It's called order of operations. Okay, if you have parentheses, you have to do that first. Then do your multiplication. If you just start putting numbers in any order, you have what's called orders of operation on a calculator. It will take the 5 divided by the 9 times the 105 and take that product and subtract 32, which is not what that says. That says you take 105 minus 32, you take that answer, multiply by 5 divided by 9. So to do this equation, you got your trusty calculator or cell phone, and you hit 105 minus 32 equals, don't hit times 5. You have to hit equals to get that number in your calculator. So don't make that mistake. So 105 minus 32 equals, and that equals 73. Then you take 73 times 5 divided by 9 equals 40.555 degrees centigrade. So 40, and it's 3 centimeter digits, 40.5, so 40.6 degrees centigrade. So there's a degree centigrade. Now you want Kelvin. Kelvin was equal to degrees centigrade plus 273.15. So Kelvin equals 40.6 plus 273.15. And that comes out to 313. I'm sorry, 313.7. And you're only good till one place past the decimal. So 33.75, that rounds the number up. So 313.8 Kelvin. Remember, significant digits with adding, subtracting, it's not the total number, it's the least accurate number. So this is one place past the decimal, that's 2 places past the decimal. Okay, so this is the least accurate number, only one place. So you can only go one place past the decimal. So you have to round that off. And then if that's exactly 5, that makes that number round up. So 313.8 Kelvin.